Hello, my dear students of Benguet State University. Welcome to our online class. I am your teacher, Jan Lasea.
Ladies and gentlemen, a blessed day to everyone. This is my sixth lecture on our subject IT 128, Quantitative Methods. Today we learn the average rate of change of a function. The average rate of change of a function is the formula function name f at b minus function of f at a divided by b minus a. Notice that the average rate of change is given by the ratio of the rise, function of f at b minus function of f at a, to the run, b minus a, from the interval a to b. This ratio is also called the slope of this second line when you connect the first point to the second point. And that is the second line. To better understand the average rate of change of a function, let us solve problems and apply it. Calculate the average rates of change of the function f at x is equal to x squared. Letter A. Between interval x is equal to 1 and x is equal to 3. Show your results on a graph. Letter B. Between interval x is equal to negative 2 and x is equal to 1, show your results on a graph. The solution for letter A is simply plug in the values for A and B into the function f. For example, the value for B will be replaced by 3. The value of A will be replaced by 1. Next, use the definition of the function, which is x squared. The value of 3 will be substituted to that x, and it will become 3 squared. The value of 1 will be substituted to that x, and it will become 1 squared. The value of 3 will be substituted to that b, and the value of 1 will be substituted to that a, and then the denominator will become 3 minus 1. The result of the quotient is positive 4. Therefore, the slope is 4. Another formula for average rate of change of a function is function of f at a minus function of f at b all over a minus b. The value of a will be replaced by the value of 1, the start of the interval. The value of b will be replaced by the value of 3, the end of the interval, divided by 1 minus 3. Next, you use the definition of the function, which is x squared. The value of 1 will be plugged in, and it will replace the value of x, and it will become 1 squared. The value of 3 will be plugged in, and it will replace this x, and it will become 3 squared. The quotient is equal to positive 4, the slope or the average rate of change. Therefore, they have the same slope. So this formula and this another formula are both the same. The solution for letter B is simply plug in the values for A and B into the function f. The value of B will be replaced by 1. The value of A will be replaced by negative 2. Next, you use the definition of the function, which is x squared. Plug in the value of 1 and replace to that variable x, and it will become 1 squared. Plug in the value of negative 2, and it will replace that x, and it will it will become quantity negative 2 raised squared raised to 2 divided by the value of b will be replaced by 1, the value of a will be replaced by negative 2, so 1 minus quantity negative 2, and the quotient is negative 1. The slope is negative 1. If we use the other formula, the value of negative 2 will replace the value of the variable a. Variable b will be replaced by 1. In the denominator, the value of a will be replaced by negative 2. The value of b will be replaced by 1. Next, we use the definition of the function x squared. We plug in negative 2 and it will replace the variable x and it will become quantity negative 2 squared. We plug in the value of 1 and it will replace the variable x and it will become 1 squared. The computed results and the quotient is negative 1, which is a negative slope. The graph of the function of f at x is equal to x squared is a parabola. It is a concave that opens upward. The average rate of change or slope of the second line between x is equal to 1 and x is equal to 3 is positive 4 and the slope is positive. Thus it is increasing, meaning as x increases, the y increases as well. The second line is a diagonal that rises from left to right. The average rate of change or slope of the second line between negative 2 and positive 1 is negative 1 and the slope is negative. Thus, it is decreasing, meaning as x increases, the value of y decreases. The second line is diagonal that falls from left to right. To draw the second line from the interval negative 2 to 1, when the value of x is negative 2, we simply plug into the definition of the function named f. So negative 2 will be the input for x, substitute it to the variable x, and it will become now 4. This 4 will be the value of y. Thus, we have the first point, negative 2, 4, for the second line, which is this point. The second interval, when x is equal to 1, we simply plug in the value of 1 to that variable x, and as a result, 1 squared, and then the value is 1. Thus, we have the second point, 1 and 1, which is this point. In geometry, we have that postulate that 2 points denote a line. So if we connect this point to that second point, that is now the second line. And then the slope of this that we computed a while ago is negative 1. It is decreasing slope. To draw the second line from the interval from 1 to 3, when x is equal to 1, we again substitute or plug in the value of 1 to the definition of the function. So 1 squared is equal to 1. Thus, we have the first point located at x-axis 1, y-axis 1 for the second line. When x is equal to 3, we plug in 3 to the variable x, 3 squared, the result is 9. Correction, it is 9. Thus, we have the second point at coordinate 3 and 9. And then we connect the first point to the second point, and here lies the second line. And then the slope is positive 4, which is increasing. Let us solve another problem. Calculate the average rate of change of the function f at x is equal to 16 minus x squared between interval x is equal to 0 and x is equal to 2. Show your results on a graph and interpret it. Again, we substitute the value of b with the end of the interval, which is 2. And then we use the function of the definition of the function, which is 16 minus x squared. This x will be substituted by the interval 2. That's why we have quantity 16 minus 2 squared to be subtracted to the second definition, or the definition of the function 16 minus x squared, and then we plug in the value of the start of the interval, which is 0. So quantity 16 minus 0 squared. In the denominator, the value of b will be substituted by the value 2. The value of a will be substituted by the value of 0. Thus, the quotient is negative 2. The slope is negative 2. That means it is decreasing. When x increases, the value of y decreases. Let us use a graphing software such as GeoGebra to draw the graph of the function and then show the second line. From the input, I will type the function f at x is equal to 16 minus x caret 2, or x squared. And I will press the enter key. And as you could see in our Cartesian plane, the graph of that function is a parabola. It is a concave that opens downward. To draw the 2 points that we connect to become the second line, I will type this command from the input, open parenthesis, the starting interval is 0, comma, function f at 0. And then I will hit the enter key. Therefore, the first point of the second line lies here. To draw the second point, I will type this command, open parenthesis, the ending interval is 2, comma, function of f at index at 2. And I press the enter key. The second point of the second line is located here. Let us connect the 2 points. I will choose the command segment, and then I will simply draw a line from point A to point B. To calculate the slope, I click this drop down button and then select slope. I will choose this line segment, and as you could see, the slope that we calculated a while ago is the same slope that this GeoGebra graphing software computed for us, which is negative 2. And the slope, or the average rate of change, is decreasing. And you can see that diagonal is falling down from left to right. This second line is a diagonal that falls from left to right. There is a better way to show the second line, which is dynamic. And I need to delete and start all over again. So I need to delete this segment. I will delete the 2 points. I will not delete this function or the parabola. I will type this command from the input to create a slider x is equal to a, and hit the enter key. And I will select create sliders. If I slide this slider, the vertical line will dynamically plot correctly onto the Cartesian plane. This slider will be our first interval. I will type x is equal to b, another slider for the second interval. Next, I will choose intersect command. I will intersect this vertical line to the function or to the parabola, so that when I slide this first slide, we can see the point that follows the path of the parabola. Next, I will again intersect this second line, the vertical line, which is the slider, second slider. So I will click the intersection between this vertical line together with the parabola. The result of the intersection between the vertical line and then the parabola is this point. And if I drag or slide the second slider, we can see that the point will move and follow the path of the curve or the parabola. Next, I will hide the vertical line, which is no longer needed. So I will click this one to make it invisible. So if I drag the first point, as you could see, there is no vertical line that follows on it. Also with the second slide, the point B, there is no more vertical line. Next, we will connect the 2 points to show the second line. So I will select the command segment. I will connect the first point A to the second point name B. And if I drag the first slider, you can see that it is dynamic. It will plot and move the point and redraw the second line. Next to that, we will now calculate automatically using GeoGebra the slope. So I will click this command slope and then select the line segment. And as you can see, it calculated the slope. So if I move the slider, automatically it will recalculate and display the updated slope. Also with the second slider, if the slope is positive, the diagonal line rises upward from left to right. If the slope is negative, the diagonal line falls from left to right. What will happen if the slope is 0? Let me see if we can create. If the slope is 0, the second line or the line is horizontal. Exactly horizontal when the slope is 0. Here is your assignment. Solve the following problems and show your solutions. The graph shows the depth of water W in a reservoir over a 1-year period as a function of the number of days multiplied since the beginning of the year. What was the average rate of change of W between x is equal to 100 and x is equal to 200? Interpret the average rate of change. Number 2. The table gives the population in a small coastal community for the period 1997 to 2006. Letter A, what is the average rate of change of population between 1998 and 2001? Interpret the average rate of change. Letter B, what was the average rate of change of population between 2002 and 2004? Interpret the average rate of change. Number 3, calculate the average rate of change of the function of f at x is equal to x cubed minus 6 squared plus 11x minus 6 between the interval x is equal to 1.2 and x is equal to 3.12. Show your results on a graph and interpret the slope. Number 4, calculate the average rate of change of the function f at x is equal to quantity 1 minus x squared divided by x between the interval x is equal to negative 0.77 and x is equal to 0.91. Show your results on a graph and interpret the slope. I posted your 6th assignment in our Google Classroom. Please answer and accomplish it.
That ends our topic for today. I hope you have learned in my class. Thank you for watching. Carry on until tomorrow. God bless us.